Good morning and good afternoon, everyone, and welcome to today's Arcserve webinar. Today's webinar is the second of our three-part series on the Arcserve UDP version 6 features. In today's webinar, we'll be focusing on UDP replication, virtual standby, and instant VM. My name is Armin Jihanian. I'm the pre-sales consultant for Arcserve, and I'll be presenting today's session. During today's session, if you do have any questions, please feel free to use the chat or the questions windows to type your questions in, and we'll answer those towards the end of the session. From an agenda perspective, it's very straightforward today. As the title suggests, we're going to be looking at UDP replication. We'll look at virtual standby and instant VM. So I've only got very, very few slides on a high-level concept and some diagrams on how these work. And then the bulk of our presentation today will be a live run-through demo on how we actually set up replication, virtual standby, and instant VM. So let's get started. Let's start with the Arcserve UDP replication. With UDP replication, we can replicate recovery points or backups between two recovery point servers or RPSs. Now these recovery point servers can be custom hardware or user-provided hardware with the Arcserve RPS software installed on it, or it can also be the Arcserve UDP appliances. Furthermore, when we can replicate from a recovery point server that's managed by from one RPS server to another RPS server managed by the same UDP console, or we can also do replication from one RPS managed by one console to another RPS managed by a different console. This might be a scenario where you have local backups that you're managing and you have your own UDP console and your own recovery point server for your local backups. And then you might be employing or using a service to provide replication for offsite backups, for example, through an MSP. When we set up replication, we can also chain replication to go from one RPS to another and to another and so on. We can chain multiple levels, and when we replicate from one RPS to another and to another, we can have different retention settings for each RPS. For example, you might have an Arcserve UDP appliance installed at a branch office. You might replicate the backups that are on that particular appliance back to a recovery point server at your production or central head office site. You might keep a lot of daily backups. You might keep 2 weeks worth of dailies on the appliance, but when you replicate back to your head office, you might only want to keep the weeklies or monthlies. You might then want to replicate whatever's in the central or head office back to a DR site. So you might have a recovery point server set up at a DR site, and then that in turn can have a different number of recovery points retained as well. So if you have different data stores on different tiers of disk, let's say you have high capacity nearline SAS or SATA drives, you might be wanting to keep more recovery points. So you have that flexibility to set different retention at different sites. You can also schedule when the replication actually starts. So you can have a replication start window between certain hours on certain days, and you can use that in conjunction with throttling schedule. So if you know that your replication might go longer and might creep into business hours, for example, you might want to put a throttle schedule in that limits the amount of bandwidth replication uses between certain hours on certain days. With Arcserve UDP replication, it's available with all editions of Arcserve UDP. From a high-level diagram view, here we have replication from one RPS to another that's managed by the same console. So this typically will be within the same organization. We have the UDP console managing each of the RPSs, and then we can see there's an optional second replication from the middle RPS to the third. When we go to do replication to a remotely managed RPS, on the source we have a UDP console that's managing the local RPS, and then we have our remote UDP server. So the UDP servers will authenticate with each other, and then the replication will happen from the RPS to the RPS directly. And again, you have an optional chain replication if you want to do that. We'll take a look at how we can set up replication when we get to the demo. The next subject, or the next feature we'll be looking at is the virtual standby capability. So what is virtual standby? In its basic form, what virtual standby does is it creates a powered off VM in either VMware or Hyper-V using a recovery point or a backup image as the base. When this VM is created, the disk for the VM is created and converted and placed on the hypervisor's storage, and that's done up front. So what happens is after your backup is made, we can then do a conversion process that will read the contents of the backup, use it as a base, and create a VM and a virtual disk, and have that powered off running in ESX or Microsoft Hyper-V server. In order to use virtual standby, we need to have a UDP console, and we need to make sure that virtual standby is configured as part of our plan. So because we're doing this conversion after backup happens, we need to plan for it, and therefore we need to make sure that we identify the machine or machines that we want to create a virtual standby VM for, and create the entry or add a task in the plan that will perform that virtual standby conversion. When we do virtual standby, we can also choose to have multiple snapshots of the virtual standby VM. So for example, if you're doing a daily backup, you might choose to keep 5 snapshots of your virtual standby VM. What this means is if you want to start that VM up, you're not limited to starting the latest backup, but you can go back and start whichever snapshot you've decided to keep. Now you can have up to 24 or 29 snapshots, depending if you're using Hyper-V or VMware. You can also, in the plan, specify whether you want the virtual standby VM to automatically start if the source server goes offline. So we can have UDP monitor the source machine, make sure that it's running and live. If it goes offline, you can have that automatically start the virtual standby VM. If that server is running a service that's business critical, that might be something that's useful for you. We can also use virtual standby in conjunction with replication. So if you've got a local backup to an RPS, and then you've replicated that recovery point to another RPS, we can then set up virtual standby at the other site. So if you have a production site and a DR site, if you've got a hypervisor, VMware or Hyper-V in your DR site, we can create a virtual standby VM in the DR site after the backup or recovery point is replicated. Now, if you need to start a virtual standby VM, that means that your source machine is not available for whatever reason, and users are accessing your virtual standby machine. It's being used live, data is changing. So if, for example, there was some hardware failure on your source machine and your virtual standby has been running for a day or two, you want to then bring your original source machine back online. What we can do is perform a bare metal restore and use the virtual standby VM as the source. So we're not restricted to restoring the older backup that was run. The VM is running, we can use that as the source to do our recovery onto the original source machine. Just like UDP replication, virtual standby is available in all editions of Arcserve UDP. So let's take a look at how the data flow works when we use virtual standby. Obviously, we have our source server. The source server might be an agent-based backup, or it could be an agentless VM backup, and we're doing our backup through our proxy. The source server is the server that has the agent on it, and the agent will create a backup or a recovery point, and that can be saved to a recovery point server or RPS, or it can be sent to a NAS or a file share. Once we have that recovery point saved and it's been backed up, starting with the VMware platform, we can use a proxy or a monitor box and then send that data to the ESXi host. So what this does is, by using a proxy, we can offload the load from the source server to do the conversion. If we don't have that proxy, that's fine. But usually, we recommend the use of a proxy so that the processing of the conversion can be done off the source machine. That will then put the data as a VMDK and a virtual machine on the ESXi host, from which we can then power on the virtual standby machine when needed. In the case of Hyper-V, slightly different. With Hyper-V, we have our Arcserve UDP agent on the Hyper-V host directly, and we restore directly onto that Hyper-V host, and then we can stand the VM up from there. So that's a very high-level look at how virtual standby works. And as I said, just like with replication, during the demo phase, we'll take a look at how this is actually set up in the console. The last feature we'll be looking at is Instant VM, or Instant Virtual Machine. Instant Virtual Machine is a feature that we introduced with Arcserve UDP version 6.0, and while it's related in some respects to virtual standby, the way it works and the use cases are slightly different. So with Instant VM, we can support the fast recovery of data directly from the recovery point. We can stand the VM up without needing to do a conversion. So what this means is there's no need to actually plan it or set it up in a plan, and there's no need for additional storage up front because we're not creating the virtual disk in a powered off state. We're actually creating the virtual disks and creating the VMs on demand. Now the way this works is we're using a combination of the recovery point or the backup as our bulk source data, and of course this is going to be a read-only source. So we then also use a differencing virtual disk to store the changes and new data. And by using a combination of that source and differencing disk, use those to provision the VM. To use Instant Virtual Machine, you need the UDP console, and you need a recovery point server, and obviously you need a recovery point, or you need a backup of the server that you want to create a VM of. Now, when we're using this combination of recovery point and differencing disk, because we've got two different sources, there might be additional latency. So if you want better performance, if you're planning on using the instant VM on a more long-term or a permanent basis, you can actually perform a storage vMotion if you're using VMware, or a VM replication if you're using Hyper-V, to get a copy of that data onto the hypervisor's more permanent storage, and that will give you the better performance because you're not running into different sources. Just like virtual standby, if you need to perform a restore, we can do a bare metal restore using the instant virtual machine VM as the source. With instant VM, this is available with Arcserve UDP Advanced and higher. So let's see how the data flow works for instant VM. So with instant VM, we're using a recovery point server with a backup as our source to start with. Let's start with VMware as our platform. What we use is an instant VM recovery server. This is a Windows server, and this can be the RPS if you want it to be. But the recovery server has the Arcserve UDP agent on it, and the recovery server, has the differencing virtual disk on it. Now, in the case of VMware, we then provide access to the original recovery point on the RPS and the differencing disk through the recovery server using NFS. So the ESX host sees the disk, sees the VM through an NFS share. And from there, we can then create and stand up the virtual machine. With Hyper-V, the concept is similar, but it works in a slightly different way. With Hyper-V, we actually use the Hyper-V host as the recovery server. The Hyper-V host has to have the Arcserve UDP agent installed on it, and the differencing virtual disk is created on the Hyper-V host itself. Once that's done, we can then provision and start the VM on the Hyper-V platform. So that's a very high-level view on the concept and a high-level view on the data flow on how these three different features work. With that said, let's take a closer look. So let's go ahead and run the demo. I'm going to go ahead and open my UDP console here. So this is the UDP console in my lab environment. We've seen this dashboard before in a previous webinar. But what we're going to do is we're going to go ahead and go to this Resources tab. And when we do that, if I click on All Nodes, here I have a list of servers that I'm backing up. First, let's take a look at how to set up replication. To set up replication, obviously we need to have a server that's been backed up, which means that we need to have an RPS, a source RPS, where the original or the first backup goes to. And then we need to have at least one other recovery point server, one other RPS that we'll be replicating to. So to see if we have that, within this Resources tab, under the Destinations heading, we can go to Recovery Point Servers here. And in my case, you can see that we have two recovery point servers. The first one here is called RPS01. And then underneath that, I have a data store. And this is just my naming that I put it. And this data store is called RPS01-DS01, the data store one. That's just the naming that I use. I also have another recovery point server here called RPS02, And this also has a data store, RPS02-DS01. Now I have some backups that go to RPS01. I have some backups that go to RPS02. And I already have some that replicate between the two already. Now if you needed to add another recovery point server, let's say you've got an existing UDP environment, but you want to use another recovery point server so you can set up replication. Well, that's easy to do. What we can do is click on Add a Recovery Point Server up here, and then we can provide the host name and IP address or IP address of that RPS we want to use, provide credentials, specify the install directory and so on, and then we can hit Save. And when we hit Save, the UDP console will push out and install the RPS software on that server. Now I've already got a second RPS set up, so I'm just going to go ahead and cancel this. But once you have another recovery point server set up, you just need to make sure it has a data store on there. Now, to set up another data store, what you can do is right-click on the recovery point server, or if you've highlighted the row, you can click on Actions, and then click on Add a Data Store. So when we do that, we've got some options here that we can define our data store location and setting. So we can give it a name, define where the data store folder is going to be. We can choose the concurrent active nodes. So this means how many tasks, simultaneous tasks, can be running in this data store. We recommend this to be between 1 to 2 tasks per CPU core on the RPS. You've then got options to enable deduplication, compression, and encryption. Now, to enable or disable deduplication can only be set when you first create the data store. Same with compression and same with encryption. You can't disable or enable these after the data store has already been created. Similarly, some of the settings within dedupe and compression also cannot be changed after it's been set and created. What you can change after creation is if dedupe is on, you can change the memory allocation to the data store. So if you want to give the data store more memory so it'll run more efficiently, you can do that. You can also choose to move the hash destination from traditional spinning disk to SSD. So those are the options that are available. I'm not going to go into too much detail about the deduplication. Most of this is beyond the scope of today's session. But if you are interested in knowing more detail about how dedupe works, we'll have our contact details at the end of the session. Please get in touch, and I'm more than happy to go through that in more detail. But for now, I'm going to cancel this again as well. Here I have my RPS1, RPS2, and I have both of my data stores. So I have what I need to get replication running. But to set up replication, I then need to go to the plan. I need to set it up within a plan so that I can tell it to do a backup and then replication. I'll click on All Plans on the left here. And you can see here I have 10 plans already in place. So I'm doing some backups, and I've created different policies and different plans for different servers. To give you an example, I've got this DC01 backup. If I click on this, I'll go into this plan. And you can see here that this particular plan for backing up my domain controller has a number of different tasks inside the plan. The first one is doing an agent-based backup. So this DC01, this is a physical box. If I go to destination under task 1, you can see that it's backing up to recovery point server RPS01, and the data store is RPS01, DS01. You can then see I have a second task, which is replicate. So if I click on replicate, you can see the source is my backup from task 1. So it's going to take the backup that went to this destination, which is RPS01. And if I click on the destination tab, it asks me where I want to send it to. So I've got my second RPS, which is RPS02. If I had other recovery point servers, I have the drop-down available, and it would have a list of all the RPSs in the console. So in this case, I've only got RPS02. I'll choose the data store. Again, I've only got one data store on this recovery point server, but if I had more, I could choose one. And then I can choose my retry settings in case there's a disruption to network or there's some issue with the replication. Next is the Schedule tab. Under Schedule, we've got this box in the top. This box will show me what the schedule is if there's a throttle in place as well. Now, by default, this will be empty. If this schedule window is empty, what that means is replication will start as soon as the backup finishes. So in this case, by having it empty, when my task 1 backup completes, the replication in task 2 is going to immediately start. If I wanted my replication to start between certain hours, I can click on the Add button here, and I can add a replication job schedule. So with the replication schedule, we can choose the start and end times and choose which days of the week we want this schedule to apply. So let's say I want replication to happen between, I want replication to start between 6 p.m. and 10 p.m. Monday to Friday. So I can set these and I can hit save, and we'll apply a replication schedule. Now this is when the replication will start. It's possible that replication will take longer and could potentially, depending on the size of the data and how much replication has to happen, it's possible that replication may expand into production hours. So what I can do is I can also add a throttle schedule, and I can click on Add, and then Add Replication Throttle Schedule. Allows me to set a throughput limit, so maybe I only want to allow 512K between 9 a.m. and 5 p.m. Monday to Friday. So I'll take Saturday and Sunday off. So if I do this during those business hours, I'll only be replicating with that much bandwidth. Underneath, I also have these fields here where I can specify what the recovery point retention will be on the target RPS. So here in this case, I'm keeping 6 daily backups, 5 weekly, and 12 monthly, and 5 custom backups when I replicate. If you wanted to keep longer or shorter, you could just come here and modify these numbers. So if I wanted to keep my backup years, for example, I could change my monthly from 12 to 36 months. Lastly, under Advanced, we have the option of enabling email alerts for the replication job. Once I've got those settings set, I can click on Save, and it will apply the settings. So this is how to do replication to an RPS that's managed by the same UDP console. If you recall, I also said you can do replication to a remotely managed RPS. So to do that, we can set it up in a similar way. I have this MySQL backup replicating to a remote RPS. So you can see here, I've also got this replicating to a locally managed one. So task 2 here says replicate. If I look at this and open the destination tab, this is replicating to RPSO2, just like my domain controller was previously. However, what I've also got set up is this task 3, replicate to a remotely managed RPS. So the source is from task 2, so it's taking the recovery point from RPS2, this is the last point in the chain, and now it's going to send it to a remote RPS. So here you'll notice that if we go to destination, we have a slightly different set of fields. Here we need to provide the address or host name or IP address of the remote UDP console. We need to provide credentials to log in or authenticate against that console. These details and these credentials will be given by the person or organization that manages the remote site. So if it's an MSP, for example, the MSP will provide you with these login details. Once you do that, you can hit connect, and then it will show you a list of available plans. So the plan here is what is available to your account. Now in this case, this plan is called Customer A, and the name I've given the plan shows the retention setting. This one gives you 7 daily, 5 weekly, 12 monthly, and 10 custom. The plan name can be set to anything, but oftentimes you'd include some sort of detail on what the retention is, so that if you're offering, or if you have the option of different retention settings, you can pick the right one. You also can set the retry period just as before. And if we go to schedule, we have the same option with the window here for scheduling when replication happens. So if I click on add, I can add a replication job schedule. So I choose when it starts. Again, if it's empty, it will automatically start after the previous task is completed. And if I want to put a throttle on that replication, I can also put a throttle schedule just as before. What you will notice, however, is that you do not have a retention setting when you are replicating to a remote RPS. That retention setting will be set by the owner and manager of the remote RPS. So that's how we'd set up a remote replication. There are more details on how to set this up and how to set the MSP site up, and again, that's beyond the scope of today's presentation. But if you are interested in seeing more info on that, please let us know and we can organize a session to go through that. But for now, let's cancel this, and let's take a look at virtual standby. Now, virtual standby, as we mentioned, needs to be set up as a task. Now, in the left here, you can see I have a heading called virtual standby, and that will be visible if you have at least one server that has virtual standby already configured. So if I click on, this will show me all servers that have a virtual standby machine available. So here, my DCO1 server has a virtual standby machine available. I'm running virtual standby on this. Now, I can further drill down and filter the different actions here for virtual standby. So if I click on action required, this will show me a list of source machines that UDP can't communicate with. So that means that machines that are potentially down and offline. So by clicking on action required, you can quickly see, is that server offline? Is it a problem? If it is, we can start the virtual standby, from the console here directly. If you want to see a list of any standby virtual machines running, we can click on this entry here, standby VMs. Source running will show us which protected machines are running at the source. And then source and VM running shows us where both instances might be running. Now when we set up virtual standby, by default it will use the same host name and IP address as the source machine. So what this means is if both are running, you have the potential of having a conflict on your network. So being able to look at which source and VMs running can be very useful here as well. Well, this is all good if we already have virtual standby running, but how do we actually configure it? So to do that, we'll go back to our plans list. And as I said, DC01 already has virtual standby configured. So let's take a look at that plan. You'll also notice that virtual standby is configured after a replicate task. Remember, we can configure virtual standby to run at a source or at a local or a remote site. So I've got task 1 as my backup. I have a replicate task that we looked at before. Let's take a look at virtual standby task. So when we open up the virtual standby task, under the source tab, we have an option to choose which side or which RPS is going to be the source of our virtual standby. Am I going to choose task 1? Am I going to set up virtual standby from my local machine? Or am I going to set it up at the remote side from my replicated side? So you can see there from the drop-down, I have the option to choose one or the other. I'm going to go ahead and keep this as my local side for this particular demo. Next, we'll click on the virtualization server. So here, we get to choose whether the hypervisor will be creating the VM on. Is it going to be running VMware, or is it going to be running Hyper-V? So here I've got a I've got a VMware server here, and I don't have a vCenter in my lab. I just have a standalone ESX server. So I've provided that ESX server's host name, the login credentials, and then if I click on this drop-down, it shows me which nodes are available as part of this server. Because it's standalone, it's showing me ESX01. If I had a vCenter and I had multiple ESX hosts, when I put the vCenter and credential details in, and I hit the drop-down list, it would give me the list of all the ESX hosts that vCenter manages. Once that's done, for VMware, we also have this monitor box. So with monitor, we specify a different server that will be keeping an eye and polling the source machine. At the same time, you have the option with this tick box at the bottom to use the monitor as the proxy to get data into the ESX server. Now this is the choice by default, and I already have a proxy that I use for backup, so I'm going to use this proxy for the restore or the virtual standby conversion as well. If you don't use the monitor server, then the source machine is going to act as the server that does the conversion. So by using the proxy, you can offload that processing to a different machine. If I was to select Hyper-V, the Hyper-V host name is specified here in the credentials. And in the case of Hyper-V, the Hyper-V host is the monitor box itself. So I'm going to go back to VMware here and keep these settings in place. And then we'll click on the Virtual Machine tab. So under Virtual Machine, this is where we can specify what the VM name is going to be. And by default, when you set up Virtual Standby, the VM is going to have the host name, the VM is going to have the name of UDP-VM underscore and the name of the server that's being protected. This is the VM name within VMware, not the host name. You can then choose how many snapshots you want to keep. So we can keep up to 29 snapshots in VMware. So I've chosen to keep 5. You can choose how many CPUs you want the VM to have and how much RAM you want it to have. You can choose which data store, which VMware data store you want the virtual disk to be created on. And if you don't want them all on the same data store, we can untick this box. And then we have a list of different servers, different data stores that we can create it on. So disk 0 might be on this 1 terabyte SATA data store. Disk 1 might be on a different one here, and so on. In this case, I'm happy to keep it all on the same virtual disk there. You then have the option of choosing which network adapters you want to use and which network they're connected to. Just like the disk, if you have multiple network adapters, you can manually specify multiple NICs. Or if you want them all to be the same type and connected to the same network, you can do so by ticking the box here. You do have different network adapter types available. And when you are doing virtual standby to VMware, UDP will try and install the VMware tool as part of the virtual standby power on process. If you have different virtual switches and networks configured, you can choose which network you want to attach to. Once that's all set, under Advanced, you have the option of automatically starting the VM. So you can see here we've got a radio button. Do you automatically start it? So if the monitor machine sees that the source machine is down, if you have this ticked as yes, the virtual standby machine will be powered on automatically. Lastly, you can set your heartbeat details and email alerts. Once that's done, next time a backup runs, there will be a conversion process that takes your backup and converts it to that virtual machine. If I was to take a look in my VMware on my VMware host, and if I look at my virtual machine, you will see that here is my UDP-VM _ DC01 VM, and it's in powered off state. It's already created it, it's ready to run, it just needs to be turned on to use it. If I need to start that, I don't have to log into the VMware console. I can start my virtual machine from the UDP console. So if I come to virtual standby here, and if I want to start the virtual standby instance on this machine, I can right-click on it. I can go to Standby VM, and if I click it, it will show me the available snapshots. So I can choose which snapshot I want to start the VM on. So maybe I want to use the latest one, which was at 7:45 this morning. I'll click on that, and I can hit Power on VM. By default, it'll use the same IP address and host name as my source. But if I click on this link down here, I can actually specify the network settings. So if I want to change it, I can hit Customize and put in my own IP address, gateway, DNS, and so on. I can also choose what kind of NIC, what network to attach, and so on. So I'm just going to exit this without saving. And just in the interest of time, I'm just going to click on the first one and hit Power on VM. You want to start? I'll say yes. So that's now going to send the command to the ESX host or the vCenter to tell it to turn that VM on. So now if I come to my VMware console, and if I refresh this screen, you'll see that UDP VM01 is now powered on. So depending on the specs of your server, it might take 30 seconds to a minute to power on. If the source machine needs to have the VMware tools injected, there will be a reboot of the instant VM, of the virtual standby VM as part of the process. So that might take a minute for it to fully power on. But we'll leave that for now. And virtual standby, if you are finished with it, we can also, if we right-click on the host and go to standby VM, we also have the option to hit power off once it's detected that that machine is up and running. So we'll let that run and we'll come back to this in a moment. But let's take a look at Instant VM. With Instant VM, it's a lot easier. If I come to my node list, I have the option to stand up any machine that I want as an Instant VM. And to do that, all I need to do is have a backup of a server, and then I might choose, for example, I might want to, maybe my SQL server went down and I want to turn that on as an Instant VM. If I right-click on that, I have the ability at the bottom here to create an Instant VM. So I'll click on that, and then I'll have the choice of which recovery point to use as the source. So maybe I want to use, if I've replicated it, I might have something on RPSO2 and do it on the remote side, or I might want to do it from RPSO1 on my local side. The latest backup was from 10 p.m. last night, so maybe I'll use this as my base. I'll go next. And similar to virtual standby, I have to choose whether I'm using VMware or Hyper-V. If I'm using VMware, I nominate the vCenter or the ESX host. But in this case, let's see how it works with Hyper-V. So with Hyper-V, I'm going to create this on my Hyper-V server called VM03. And I'll go next. So if you recall, with Hyper-V, the recovery server is the Hyper-V server. So this screen is basically telling us that the Hyper-V server, it should be Windows 2008 R2 or above, and you should have the UDP agent installed on it, and that machine should be in the list of servers in the console. All of these conditions are true, so I can click on Next. Next, we have the VM name. So similar to UDP's virtual standby, when you create an instant VM, it will put UDP IVM underscore as the prefix, then have the host name or the node name. You can put a description in if you want, and then we get to choose where we're going to create that differencing virtual disk, and that's this VM files folder. So this is going to be on VM03 because that's the Hyper-V server I nominated. So if I click on, if I click on Browse, I can select which drive I want to create my differencing disk on. Now I think I've already created one. There it is, DIVM. This is just the folder that I've nominated in the past to use and create my differencing disks on. And then we can choose the CPU count on the virtual machine and the RAM. So with this one, I might want to use 4 gig of RAM or more. And with Instant VM, you need to manually specify your adapter and IP address. So what we can do is add an adapter in. You can choose which network and what kind of adapter you want to use. You can then choose to get IP address through DHCP, or you can manually specify those settings there. Now I'm not going to add a network adapter here. I don't want to put this SQL Server online on my network just yet. So I'm going to go ahead and click Finish. And then you have the option to immediately turn the Instant VM on or to boot later. I'm going to choose boot later just so I can show you what it looks like to start the VM through the UDP console. So that's now in the process of going ahead and setting up that VM. While that's doing that, let's take a look at our VMware console and see if that virtual standby machine has come online. So here it has. If I click on this, there's my machine. If I send Control-Alt-Delete, so I can log into this machine and you can see that the VM is running. So while that's logging on, let's go back to our UDP console and look at our instant VM machine. So here we can see that this instant VM is now under this infrastructure setting. We have instant virtual machines, and this instant VM is listed here. This icon is telling us that it's currently powered off. So if I right-click on it, I can click Power On, and that will go ahead and start that VM up. And that's going to start that VM on the machine called VM03. So what I'm going to do, I'm going to open up a remote desktop into VM03. So I've already got the Hyper-V Manager open here. So here is VM03. Here's some VMs that are already on this Hyper-V host. And then here is UDP IVM SQL01. So this is the instant VM that we just started. So if I double-click that, we can see that Windows is in the process of starting up on this machine here. Now again, the speed of this is going to really depend on your environment and your equipment. This is putting a little bit of strain on the resources on my box here. But you can see that Windows is in the process of starting up here. I'll come back to the UDP console. You can see here the icon has changed from the standby or powered off icon to this play icon. So this VM is currently running. Once I'm done with the instant VM, I can right-click on this and I can choose to just power it off, or I can completely delete it. With the virtual standby machine, I have a similar option. If I come to the standby VM running, so we can see here this is running, I can right-click, and if I click on standby VM, you can see here that this snapshot is active. It says active next to it. This is the one that I stood up. If I click on this, I then have the option to click Shutdown VM, and it will go ahead and turn that VM off. So with that, that pretty much covers most of the demo that we have planned for today. Before we get to the questions, I did just want to mention that this was the second in our 3-part series on the UDP version 6 features. In 2 weeks' time, we're going to have our last webinar in this series, and that's going to be looking at UDP cloud and tape integration. We're going to take a look at how to do file copy and file archive, both to on-prem and to cloud platforms. So that includes Object Store for Amazon, Azure, and others. We'll also look at how we can do copy recovery points to tape if you need long-term retention or for compliance purposes, how we can put our recovery points to tape. But that's on Friday the 2nd of September at 12 o'clock Australian Eastern Standard Time. And if you want to register, the registration link, you can follow that URL on screen and follow that to actually register. I mentioned it before, but again, if you're interested in more information, if you want a deep dive, if you're interested in particular features in more depth that we haven't covered or even features we haven't looked at yet, by all means, please feel free to contact myself or my colleague Andrew. Our details are on screen. So I'm going to leave this up for a bit, and I'll now open it up if anyone has any questions. I'm just going to take a look here in the questions pane. I can see we've got some questions here. So there's a question about a way to get a single report for all jobs rather than email alerts. There is a way that you can actually set up a report that gets sent out proactively. You can set that up to come through to you daily, for example, like 7 or 8 a.m. And that was actually covered in one of the earlier webinars in the UDP Basics series when we looked at the UDP console. We'll include some links to the previous recordings, so you can take a look at that and see the flow on how that's configured back in that particular session. And then the next one is with Instant VM or virtual standby, if they get used in production, how do we get the changes back to the original machine? So that's an excellent question. So you've spun up your virtual machine, you're using virtual standby or Instant VM while your source machine's gone down. That's now up and running again, but you need to get your data back. What we can do is a bare metal restore to get the data from the VM back onto the source machine. So instead of using a recovery point or a backup image as our restore source, we're using the VM itself as the restore source. I'll again refer to the last webinar we just had about bare metal restore. There was a screenshot that showed how you can choose either a recovery point or a VM as the source. So again, we'll make sure that the recording links are available, and you can take a look and see where that is when it comes to do bare metal restores. So we've probably got another minute or so. And yeah, we just had another question come through. Can you do Instant VM to go between hypervisors, Hyper-V to VMware or vice versa? The answer is yes. We can use it to do P to V, V to P, P to P, sorry, no, virtual standby and Instant VM or VM. So we're looking at doing P to V, V to V conversion. So you can use it to go from one hypervisor to another. You can even use it to go from a different hypervisor that's not even VMware or Hyper-V, and have the target be Hyper-V or VMware. All right, we'll start looking at wrapping it up then. So if there are no other questions, I would like to thank you for your attendance. If you do think of any questions after and you wish that you had just typed it in or just thought of it after the session ended, please take down my details. Please feel free to contact me, and I'm answer those questions if they come through. But again, I encourage you to register for the next webinar, which is on the 2nd of September. 2nd of September. And until then, I'd like to say thank you again for your attendance, and hope to see you at the next webinar. Thanks.